Imagine being able to rewind time and watch a person's movements on a map, minute by minute, street by street, using nothing but their phone. That's the promise people imagine when they hear cell phone forensics on crime shows. A detective points to a red dot and declares, "The suspect was here at 9:17 p.m. Case closed," right? Reality is messier and way more interesting. Cell phone location data is powerful, but it's not magic. It's a mix of radio signals, network logs, GPS chips, Wi-Fi breadcrumbs, and a lot of careful interpretation. Used correctly, it can support the truth. Misunderstood, it can send investigations and even juries in the wrong direction. In this video, we're going to unpack Cell Phone Forensics 101, what location data really shows, what it can't show, and how professionals actually use it. By the end, you'll be able to watch any "we pinged his phone" moment with a much more critical eye. Before we dive into towers and GPS chips, let's set expectations. This video is a beginner-friendly guide to how cell phone location data is created, collected, and interpreted in real investigations. We'll walk through call detail records, cell site analysis, app logs, and why every data source comes with a built-in margin of error. You don't need a technical background, just curiosity and a willingness to think critically. If you enjoy unpacking how digital evidence works in real cases, this channel is for you. Consider subscribing and turning on the notification bell so you don't miss future deep dives into forensics and tech in the justice system. Stay with me until the end, because we'll finish with a rapid-fire checklist. What you can conclude from location data, what you definitely can't, and a few practical tips to better understand your own digital footprint. For now, let's start with the most basic building block: how your phone talks to the network. Every time your phone connects to the cellular network, whether for a call, text, or data, it does so through a nearby cell tower. Think of towers as lighthouses broadcasting radio signals. Your phone listens for these signals and responds to the one it can use best. A cell tower typically covers a geographic area that's split into sectors, like slices of a pie. Each sector has an ID, a direction it's facing, and a rough range. When you place a call, the phone connects through one of these sectors. The carrier logs that interaction. Those logs become what investigators call cell site location information. It doesn't give an exact dot on a map. Instead, it tells you which tower, and often which sector, the phone used at a specific time. That means location is inferred, not directly measured. The phone was somewhere within that sector's coverage area, with signal strength, terrain, and building density all affecting how far that area reaches. Call detail records, CDRs, are the backbone of many cell phone forensic analyses. Whenever you make or receive a call, send a text, or use data, your carrier logs certain details. For location work, investigators care most about timestamp, tower ID, sector ID, and sometimes additional network parameters. A CDR might say, at 21:17:32, this phone placed an outgoing call that lasted 3 minutes, routed through Tower 123, Sector B. On its own, that doesn't sound like much, but map that tower's location and sector direction and you get a possible area where the phone was during that call. Carriers store these records for limited periods, months or a few years, depending on laws and company policy. They're primarily for billing and network management, not built as forensic tools. That's important. Investigators are repurposing operational data, which has quirks and gaps. Understanding those quirks is essential to avoid overclaiming what the records can prove. So how do we turn those raw tower and sector IDs into something visual? Enter cell site analysis. A trained analyst takes CDRs from a specific time frame, pairs them with a database of tower locations and sector orientations, and then plots each connection on a map. Typically, they'll draw a sector arc, a wedge extending from the tower in the direction the antenna faces, with a radius representing approximate range. Any phone that used that sector was likely somewhere within that wedge. By stacking many events over time, patterns emerge, where a phone tends to be at night, commuting routes, and whether it plausibly could have been near a crime scene at a certain time. But there are caveats. Coverage areas aren't perfect wedges. They bend and shrink around hills, reflect off buildings, and shift when towers are busy. Analysts often do drive tests or use propagation tools to understand how a specific tower behaves in the real world. TV often shows a blinking dot on a map, as if cell data gives GPS-level precision. In reality, sectors can cover anything from a small neighborhood to many square miles, especially in rural areas. Several key factors shape that size. First, tower density. In dense cities, multiple towers cover smaller overlapping zones, so sectors are tighter. In the countryside, one tower might serve an entire town. Second, frequency and power. Higher frequencies tend to travel shorter distances, and carriers tune power levels for capacity and interference, not forensic needs. Third, environment. Mountains, water, steel buildings, and even foliage can warp signals. A phone might connect to a farther tower if the closer one is blocked or congested. The result: if a record shows Tower A, Sector 1, we might reasonably say the phone was in a broad directional area, north of the tower, for example, but not that it was at a particular house, store, or parking spot without additional evidence. Cell towers aren't the only location source on your phone. Modern smartphones combine several different systems, each with its own strengths and weaknesses. GPS uses satellites to triangulate a fairly precise position, often within a few meters, but it works best outdoors with a clear view of the sky. Indoors or in urban canyons between tall buildings, accuracy drops or signals vanish. Wi-Fi positioning uses databases of known router locations. If your phone sees certain networks, it can estimate where you are even with GPS off, based on prior mapping. Bluetooth beacons, accelerometers, and barometers can refine movement and elevation. Think floor level in a building, but that's more common in specialized systems. App-level location data, like from navigation apps, rideshare services, or fitness trackers, can log highly granular routes and timestamps. However, access to that data usually requires device seizure, cloud warrants, or user consent. Each source has its own timestamp formats, time zones, and accuracy notes that must be interpreted carefully in context. A powerful part of phone forensics is building a timeline, turning scattered records into a narrative of movement. Analysts often start by listing key events: calls, texts, app sessions, GPS fixes, Wi-Fi connections, and tower changes, all stamped with times. Then they align those events on a unified timeline, correcting for time zones, daylight savings, and any known clock drift. Mapping each event creates a series of possible locations over time. Instead of a single dot, you get a trail of areas the phone could have been. This lets investigators test scenarios. Could the phone have traveled from location A to location B between 9:05 and 9:17? Does the pattern match a claimed alibi, like being at home all night, or does it suggest movement inconsistent with that story? Crucially, gaps in the data matter too. Periods with no activity might mean the phone was off, in airplane mode, out of coverage, or simply idle without logging location at all. You'll often hear phrases like, "the phone was in the vicinity of the crime scene," or "at the victim's house." In a forensic report, those words should be used very carefully. Location data usually supports probabilities, not certainties. Analysts might say, based on multiple connections to a specific sector that historically serves this address, plus drive testing confirming coverage, it's likely the phone was in this neighborhood. That's stronger than a single brief connection, which might just show the phone passing nearby on a road. Moreover, the phone's location is not the same as the person's location. Someone else could be carrying it. It might be left in a car or at home. Good practitioners phrase opinions with qualifiers: consistent with, compatible with, cannot exclude, rather than absolute language like proved or definitely at. When those nuances are lost in court or in media coverage, the evidence can sound far more precise than it really is. Just as important as what location data can show is understanding its limitations and sources of error. Coverage maps are models, not reality. Weather, new buildings, temporary outages, and network reconfigurations can all change which tower a phone uses on a given day. Device behavior adds more uncertainty. Different phones and operating systems manage power and signal differently. A phone might cling to a weaker tower longer or aggressively hand off to a new one. Background app activity can trigger unexpected data connections that appear as location events. Timestamps aren't always perfect either. Logs can be in local time, UTC, or carrier-specific formats, and misinterpreting them can shift events by hours. Clock drift on the device itself can throw off app records. Finally, data can be incomplete. Carriers may purge older records, or particular sessions might not be logged. Analysts must always acknowledge when conclusions are based on a partial picture, not a complete continuous tracking feed. Real criminal cases increasingly hinge on phone location evidence. Used well, it can confirm alibis, place suspects near key events, or exclude wrongly accused people. Used poorly, it can mislead juries. A strong analysis typically combines multiple data sources: CDRs for broad movement, GPS or app data for finer detail, surveillance footage, witness statements, and physical evidence. If everything lines up, tower use matching a car seen on camera, matching a navigation route, that's compelling. But there are cautionary tales. In some cases, prosecutors overstate precision, suggesting a phone was at a specific house when records only show a sector covering several blocks. Defense experts sometimes reveal that drive tests show coverage extending far beyond what the original maps suggested. Courts in several countries now issue guidance reminding judges and juries that cell site evidence is one piece of a puzzle, not a standalone tracking device. The trend is toward more rigorous, transparent explanations of what the data truly supports. Whenever we talk about location data, we have to talk about privacy and consent. Many people are surprised by how much their devices log by default. Carriers keep connection records. Apps may collect continuous GPS. Cloud backups store years of movement history. Law enforcement access to this data is typically governed by warrants, subpoenas, and evolving court rulings. In some jurisdictions, historical cell site data requires a higher standard, like probable cause, because it can reveal long-term patterns of life. From a user perspective, you do have some control. You can limit which apps have location access, turn off background tracking, or periodically clear certain histories. But turning off everything comes with trade-offs. Navigation, emergency services, and basic connectivity all rely on some level of location awareness. Understanding what's stored, by whom, and for how long empowers you to make informed choices, rather than assuming your phone is either completely private or completely exposed, neither of which is true. If you're a student, lawyer, investigator, or just a true crime enthusiast, how can you critically evaluate location evidence when you encounter it? First, look for specificity. Does the presenter clearly state whether the data comes from towers, GPS, Wi-Fi, or apps, or is it just called phone location? Vague labels are a red flag. Second, check the language. Are they saying the phone was in the area of or exactly at a place? Are margins of error and alternative explanations discussed? Third, ask about validation. Were drive tests done? Are there photos or schematics of the tower layout? Do they explain coverage in that particular environment, or rely solely on generic ranges? Finally, see how it fits with other evidence. Strong cases don't rest on location data alone. When you practice applying these questions, you'll spot when stories stretch beyond what the technical record can honestly support. Let's pull together the main points from this crash course in cell phone forensics and location data. First, cell towers and sectors give approximate areas, not pinpoint dots. CDRs log which tower and sector handled an event, and analysts infer a likely region from that. Second, multiple technologies contribute to location. GPS, Wi-Fi, app data, and sensor fusion can add much more precision, but only when available and properly interpreted. Third, coverage is messy. Terrain, buildings, network load, and device behavior can all influence which tower a phone uses. That's why good analyses involve testing, not just theory. Fourth, conclusions should be probabilistic and clearly worded, consistent with being in this area, and should always separate phone location from person location. Finally, context is everything. The strongest cases combine location data with corroborating evidence, while respecting legal standards and privacy concerns. With these principles, you're now equipped to question and better understand any "we tracked the phone" claim you hear. If you've watched this far, you now understand more about cell phone location data than most people who casually talk about pinging phones on TV. You've seen how towers, sectors, GPS, and apps each play a role, and why careful interpretation matters. If you found this breakdown useful, consider subscribing and hitting the notification bell so you don't miss our upcoming episodes on other kinds of digital evidence like car infotainment systems, cloud backups, and social media metadata. It really helps the channel reach more people who care about how technology intersects with justice. I'd love to hear your thoughts. Were you surprised by how imprecise tower data can be? Do you want a follow-up episode where we walk through a mock case step by step, building a location timeline from raw records? Drop your questions and ideas in the comments. Thanks for spending part of your day here. Stay curious, stay critical, and I'll see you in the next deep dive.